units. This is our second and last lesson of the week. And if you were at school, what you would do, in normal time, you would do an investigation. We will investigate the principle of moments. In other words, we will try and find out, confirm whether the condition for rotational equilibrium is that the anti-clockwise moment is always equal to the clockwise moment. How would we do it? So we would have one of these rulers, okay, balancing. Okay, it's a bit of a tricky investigation, I gotta say. We'll have to first balance it. And then we will put different weights, different masses and different distances from the equilibrium. Note down the weight itself, the force pressing down, and the distance on the one side, and try and balance it with another weight and find out what distance does it have to be to create an equilibrium. Okay? It's a bit of a fiddly experiment to make sure it's balanced, but it can be. Okay? So what I did, I made up some data for you. So you can see that on the left side, okay, we're going to choose different forces, and we're also going to choose different distances. This investigation is a bit tricky to actually perform, but also the table is quite big, so it can be a bit confusing. What's an independent variable, what's a dependent variable, okay? It's a bit tricky, okay, but I will take you through it. So we'll choose different forces. You see I chose 1, I chose 1 again, okay, 2 and 3 and 3. But what I also changed is the distance from the pivot. So both cases where I chose 1 Newton, you think like, why would I choose 1 Newton the same? Well, what I varied is the distance from the pivot. So the first case I used 1 meter away, and the second case I put to the force 2 meters away. So I'm not just changing the force, I'm changing also the distance. What I'm really changing and what my independent variable is the anti-clockwise moment. Okay? Because force times distance is your anti-clockwise moment. Then in any case, I will balance that every time with a different force and determine what I need to find out. What is the distance that I had to put that force? So let's fill in this table for you. The first thing you need to do is fill in the table. Okay? If the force on the left is 1 Newton and the distance is 1 Newton, what will be the anti-clockwise moment? What will be the force and the distance on the left side? Because this caused anti-clockwise moments, okay? So it's going to be 1 times 1, which is equal 1. Now, if the units of the force is Newton, the units of the distance meters, the units will be also obviously Newton meters. So the answer is 1. I'm going to run this 1 times 1 just so you will see it. You need to do it. Next thing, what is the force time distance here? What's the anti-clockwise moment when I use 1 Newton 2 meters away? Well, it's going to be 1 times 2, which is 2 Newton meters. Do one more and then the rest you guys do on your own. Okay? When I use 2 newtons 2 meters away, the anti-clockwise moment will be 2 times 2, which is 4. So on your table, you should have 1, 2, and 4. I'll let you do those two on your own. Okay? Now we've got to calculate for each one of those what the clockwise moments. Again, because we use Newton meters, the unit will be Newton meters. So now I've got to look on the forces to the right. These are the anti-clockwise moments, F2 and X2. Okay? So 2 times 0,45 is 0,9. 1 times 2 is 2. 4 times 1.05, I don't know what. Okay? Let's use a calculator. 4 times 1.05, 4.2. Okay? So we calculated the anti-clockwise moments and the clockwise moments. You still need to do it to those two. What I'll ask you to do after you've done that, so the first bit I did pretty much for you, what you need to do then is draw a graph. Now I'll put the graph paper underneath this lesson. If you've got a printer, that's the best thing, just print that. If you don't, just draw the graph as best you can in your book. Okay? So first of all, you need to have a title. Okay? Remember, title is always independent variable and versus dependent variable. The independent and dependent, what did we change? Well, we changed the force, the distance, but eventually what we changed is the anti-clockwise moment, so that's your independent variable, and the clockwise moment, that's what we measured, so that's your dependent variable. So you need to have anti-clockwise moments versus clockwise moments. Okay? Give that for you. Here is what you change. What did you change? That's going to be the anti-clockwise moments. Okay? Because that's the independent variable. This is going to be the clockwise moments. Okay? With the units. Don't forget the units. And then we plot our graph as normal. Okay? What can be a bit confusing is that we've got so many columns. But when it's time for us to draw the graph, all we're interested is the independent and dependent variable. In other words, all we're interested is this part of the table. We forget about that. Don't get that confused. These numbers are just there for you to calculate the clockwise and anti-clockwise moments. Once you calculate them, you don't need that. The only thing we plot on the graph is the anti-clockwise moment and the clockwise moment. You plot a graph, you know how to do it with crosses, not dots. You draw a line base fit, whether it's curve or straight. You don't need to go through all the points. Guys, this whole exercise is just for you to practice a bit of graph skills. We haven't done it in a long time. And you know, in test, I like to put a graph question. Okay? So try and draw a straight line or a curve, whatever you think fits, that doesn't necessarily touch all the points, but is as close to all points. And secondly, it has an even scatter. Similar number of points above and below. Okay? Use a pencil, because you will probably need to correct. You might have to correct. Okay? And that's it, guys. Okay? Have a lovely day. Enjoy your week. I'll see you next week.